Hey, welcome to the 15th episode of Distributed.NET Core course. It's Peter
Derek.
And before we begin, this is going to be our final episode, at least for now, right?
Yep. Actually, we discussed some other topics, but we decided that this will be a good, solid ending for the whole series. And actually, at the beginning, we didn't plan to make this episode, but so many of you requested this that we actually, are going to make it. So
Yeah, and I think actually it'll be a good ending because you'll see how you can deploy your apps into the virtual machines or in the cloud. And today we'll focus on this deployment part. We'll start with basic tools running on bare metal virtual machine, and then we'll go deeper, and you'll see how to use some tools or some user interfaces with web dashboards to manage and orchestrate your applications. All right, so what do we have here? If you open, or at first, if you pull the latest changes for the DShop repository, you can find it under the compose directory. We added the demo directory, and here we have 3 files. So basically, these are the Docker compose files. The first one is called infrastructure. So this Docker compose file, contains all of these infrastructural services like Consul, Fabio, Grafana, Mongo, and so on. So instead of keeping them in a separate files, we have them all here in a single file. And we have another file for the services in which we keep our APIs and all of these microservices that can talk to each other. And you can basically run the Docker compose for this one and then for this one, and everything will be up and running. And of course, we have this Prometheus file for the Prometheus monitoring configuration. And now let's assume that you would like to deploy your application somewhere, whether it's production environment or testing environment, whatever. And you want to deploy it somewhere, so anyone, whether it's your intranet, whether it's on-premise deployment, whether it's cloud deployment, you want your apps to be publicly accessible somehow by the other people, by the other users. Just like we started doing all of these, as we started using all of these tools in this course, we are cloud agnostic. So we will not tell you something like go to Azure, go to AWS or something and use their services. I mean, you can do it, but we want to show you how you can do this in a more generic way. So
that's actually why we had some thoughts about this episode, because it would make no sense to show you the example in the Azure, let's say, because pretty much the deployment part is very, I would say, pretty much depends on your company that you work for, or some other stuff. So it would make no sense to show you just one way, because at this point it's pretty up to you and depends on many factors. So this is the generic way of doing this.
And
but hopefully we'll just show you some basics of the more or less DevOps stuff.
Mm-hmm. Some things, of course, can be done easier. For example, if you decide to go to Azure, Google, or Amazon, you will find here a lot of built-in integrations with Kubernetes and other services. So basically, you could just click on it and have everything up and running. But you will see how to do it on your own and how to do it on premise in different environments where you maybe can use cloud, or you want to have something up and running in your local network.
Just one more thing, because that was quite interesting what you just said. That just keep in mind that being the cloud agnostic is for the educational purposes. That was really cool, because we showed you a lot of stuff like the service discovery and other managing, playing with the Docker and so forth. So what's underneath and how does it work and so forth. But on the cloud, some of these problems that would not even exist, right? If you would put this on some service fabric or service fabric mesh, that would be way easier because the platform takes care of some stuff. So the same goes here. We will do some additional steps, and some of them could be skipped in a cloud. But by doing this, even complicating stuff, you'll simply learn what's underneath, and it will be much easier for you to understand this in the future. So
yeah. So let's do the first step of deployment. So here I logged into my account on the DigitalOcean cloud. And within this cloud, I would like to just start a virtual machine. So here it's called Droplet. So I can just click here, create droplets. I mean, as you can see, they also added some built-in services for actually clusters for Kubernetes, but we'll stick to the Droplet, which is just a virtual machine. So here I will pick maybe Ubuntu distro. I can go with this one, $20 per month. And let's put it in Frankfurt. I'll also enable here maybe these 3 things. And I want to select my SSH key because I don't want to use the passwords to log into my virtual machine. I just want it to be done with the SSH key. So I will set it up here, and I will just call it maybe something like DShop system. Okay. And I want to just create one droplet, one virtual machine, and we'll set everything up. So while it's creating, what we're going to do, we're going to log into our Linux virtual machine, install Docker Compose, and let's see what we can do about it. So how to install Docker on your virtual machine? Maybe if you've never used Linux before, well, it's very simple. You can just type something like Docker install, maybe let's say Ubuntu. And here you can find links. For example, here there is a link to this DigitalOcean site, the same one that we are using for hosting, for these demo purposes. And here, for example, you can find how to install the Docker on the Ubuntu virtual machine. Okay, so let's see if it's up and running. Okay, I can grab the ID. And I should be able to log into this one through the terminal. So SSH root at this IP. Let's wait because it always takes some time when you create it for the first time. But in a few seconds it should be up and running. Okay. So now I'm logged into my virtual machine. As you can see, there is no Docker, so we have to install it. And we can do it either like this, but actually I'm not sure which version we'll install, 1806 CE.
I think that looks like the newest one.
Okay, maybe we can try with this command. So let's see. So let me try to do it like this. It seems even simpler. Oh, sorry. Like this. Okay. So it seems that it's just a single liner. As you can see, you don't even have to go through this type of installation. You can do it with apt.
Pretty simple.
So, yeah. And since Docker is like a native for the Linux, it's very, very fast. So, as you can see, we have already Docker up and running on our virtual machine, which is cool. We also have the Docker Compose, I guess. We don't. Okay. Sometimes it was installed along with the Docker, so let's install the Compose.
That's weird. I was sure that the Docker Compose is now the part of the Docker.
I mean, it's usually installed with Docker, but sometimes.
Or maybe that was the Swarm. The Swarm, at some point, just turned into the integral part of the Docker.
Yes,
not the Compose
Docker
itself.
Swarm for sure, but with Docker Compose, sometimes you would get it installed along with Docker, but the version would be wouldn't be really up to date, and you'll have to install it on your own. But again, you can install like this, or you can just type Docker Compose, install Ubuntu, and another link to the installation guide, whether it's this one or this one. And this is basically like a 3 commands. Two commands to install Docker Compose as well. Okay, so now that we have this stuff here, and we also have the Docker Compose. This is an old version. Okay, so we installed the old version. So let's install the new one, because this one, I'm afraid, won't support our newer Docker Compose files with version 3.5. So let me do it this way. And basically,
So the new one was 18.04.
no, the new one is actually 1.240. So if you go to this Docker Compose releases directory, sorry, this one, you can look for the newest versions here. And as you can see here within this command, I have this 1.23, and I'll just make it 1.24, then 0, and paste it here. Okay, and it will grab this latest release, and let's just make it available. So, okay, let's check now. Okay, maybe, let's see, Docker Compose. Maybe we'll have to, let me just check. It could be that sometimes you might need to reboot your virtual machine, which shouldn't be the case in that scenario, but if it's the older version, that's fine for now. Yeah, I wanted to do it the original. Oh, it works. I had to log out and log in again. So sometimes these simple solutions works. Okay, so we are good to go. We have the newest version of a Docker Compose. So what we can do now? Well, we could basically grab this compose file from here and just run it. So I could do something like nano, and maybe let's docker compose YAML. Paste this stuff here, save it.
Yeah, you picked the easy path because you chose the nano.
Yeah.
Instead of
I can do with VI as well. So it just WQ. Escape.
You know how to
WQ.
quit Vim.
Yeah.
Wow.
Yeah.
I would restart the VM. Yeah.
We have the Docker Compose now, and I could just type Docker Compose up, right? And it will start all the services. And if we have our ports exposed here, for example, as we have here, we will be able to reach our services, right, from the outside world. You just have to keep. Yep.
Just to make it clear, because you might not remember, the reason it works is because we put all our images. First, the infrastructure itself is of course available on the Docker Hub, but we also have all our images available, and they are public on the Docker Hub, right? So
that's correct.
This is used inside the
That's
Docker
correct.
Compose. So there is no magic behind this.
Yeah.
It simply takes the image from the registry.
All of these images are public, these ones, and also our custom images.
Yeah.
But if you were to use your own private registry, then you would have to change the configuration of your Docker, change the registry URL, or you could just do something like Docker login, Docker login, then my registry, whatever.com, login, and then start the Docker Compose once again, and it will fetch the new images from your private registry. Yeah, or you can also change the registry in a global Docker configuration available within your system. One thing to keep in mind, because that would work, right? So you could expose some of the services in that scenario. We would expose only the API and the identity service. The other ones, we would remove this port section from the other services. The same goes with the infrastructure. We could probably hide all of the infrastructure. Remove all of these ports and just make it run internally, and will all work just fine. However, if you would like to expose your services, and then on top of it, you would like to maybe install Nginx, like you would like to install Nginx or Apache or some other HTTP server and use reverse proxy mechanism to move your traffic to your services, and then add some load balancing, SSL certificates and so on. You have to be aware of one thing. Because on Linux, you can install this UFW firewall. So you can install the UFW firewall, and with UFW, you can allow or deny some ports. Like let's just take with the typical firewall. And if you were to start your Docker containers and expose services like this, the UFW, well, you could set deny this port, but it will still work because, well, Docker, just to make it sound like a little bit trivial, Docker doesn't really care. I mean, it uses different mechanism for resolving the ports and letting the request or letting these connections, reach those ports, so that it will basically omit your firewall, at least the UFW. So if you like to run these services run these Docker containers in a way that they are still available but only on the local host, then simply bind them, for example, like this, and it'll be just fine. So this is your local IP address, your local port, and then your private Portainer code. So this is something that I learned some time ago.
Yeah, that's a good note.
Yeah. All right. But, well, I think you should understand by now that it's very simple to run all of our stuff through Docker Compose and just publish ports, and we can reach the app from the outside world simply by taking its IP address and let's say 5000, and given that I would have the API up and running, I'll be able to reach it, which of course I am not able to do it right now, correct? So, but we'll not do it like this because, as you can imagine, it can be quite a pain to manage all of your infrastructure by logging to your virtual machine and then updating your images, restarting them, and so on. One cool thing, or actually one cool tool that you can use, especially maybe let's say you like to do it this way. You have some small deployment, or you want to quickly set up the staging or testing environment. There is this tool called Watchtower, and let's make it Docker Watchtower. And basically, you run this. Well, who would have guessed? You run this through the Docker, and what the Watchtower does, it will periodically check for the newer version of your images, and it will just update them. So you don't have to set up any kind of webhooks. It will just, for example, every 30 seconds, ask for example, Docker Hub repository, is there a new version of this image? Is there a newer version of this service, of the customer service? If there is, I will pull it and recreate the container. So you will always have the newest version of your API or your application up and running.
But
yes,
is it based on some sort of configuration file to just say that I want to watch for my
watch for? I think you can change here. You can only change the this system's Docker configuration here, so you can plug it in. So I think it's possible to point it to your private repositories. You have few additional parameters like interval. They are here. Schedule using cron expression and so on.
What I meant was like I would like to watch for new changes for my services, but I would like to keep my infrastructure at the same version that I put it at the first time. So
I see.
Can we distinguish, or just
I think
point to the specific compose file or something? That would be.
I'm wondering whether with this label enable it's possible or not, because it says watch containers where the label is set to true. So maybe you can maybe if you enable this one and label your containers with this tag, it will just look for the containers that are tagged with this value.
Yeah, okay.
So I think that will be this option, but I'm not sure, but I think it will be the one. Okay, so what we'll use instead, let's make it a little bit more rich in terms of the user interface. So there is this cool tool called Portainer, and basically Portainer gives you this very nice user interface to manage your services running through the Docker. And how we can start? How we can start using it? Well, go to the installation tab, and simply.
Who would expect?
Yeah.
Install this
again.
Docker,
we can run it through the Docker. So here we can either use the single host, or we can also run it through the Docker Swarm. We'll not get into the Docker Swarm because it's a different orchestration tool that we'll not be using in this episode. but you can also integrate it with the Swarm and run it as a Swarm service. So let's stick to this basic scenario. I will just copy this first command into my virtual machine. Let's see. Okay. I will create a volume for the Portainer, and then I will run the Portainer like this. Okay. So it will pull the container from Docker Hub and run it on this local host 9000. So right now I can copy my the IP address of the virtual machine, and I should be able to open this one. What's this one?
Yeah, under details. Visit this unsafe site. The below at the very bottom.
Oh, okay. I don't know. I'm not sure what it says that it's. I didn't run anything using DSL here. It's weird. I will try with HTTP. Let's see. I don't want this warning. Okay, that's weird.
You'll have this anyway.
Whatever.
Maybe, yeah.
Yeah, that's fine for now.
Some additional configuration. Yeah.
Yeah, it used to work. It shouldn't show me any errors here, but whatever. Okay, so right now I will log into my Portainer. At first, you have to set some password. No, and here you can decide what type of environment would you like to manage. So the cool thing about Portainer is that you can actually manage the remote environment, and you can connect agents to your Portainer. So you can basically make it, enable this high availability option here. But we'll stick to the local environment. Let me connect. And as you can see here, there is my local environment. And let me get into this one, okay? So right now I'm actually running Portainer on my virtual machine. So I'm running both the agent and the server, so to say. So what I can do about it? Well, I can do a lot of cool things. I can go, for example, to registries, and I can add my custom registry, whether it's Quay, Azure, or some custom registry that can be, protected. So here I will just simply provide my username and password, the URL here, and that's all I need to do. I can enable some access policies. They also added some extensions. I haven't used them yet. I have some basic information about my host. As you can see, there is 4 gigs of RAM. And here I have the tabs where I can, simply manage my volume. So I can, for example, create a volume here. I can create a network. Let's say I like to have this bridge driver network named DShop, so I can create it here. And the important part is that I can manage the images. So as you can see, there are all of the images currently available on this virtual machine. I can manage the containers, and I can manage the stacks. So either I could go into this container section and just click add container, and here provide a name. Let's say I want to have the RabbitMQ. The image would be RabbitMQ management. And here I can set up all of these volumes, networks, variables, and so on and so on. So this is the same thing that you can do with your Docker CLI. Just in that case, you don't have to use the CLI. You just have the interface for that. But the other thing that you might find quite useful is the stacks. So with add stack, you can just copy and paste the Docker compose file. So let me try to do it. I will copy the compose file for the infrastructure, and I will put it here. There are 2 important things to remember. If I will try to click deploy the stack now, just have to provide a name. Let's call it infrastructure. I will get an error, and it cannot do whatever it is. It cannot process this string 3.5, this version. And you can see they say that only version 2 is supported. And as I look through the GitHub, they also mentioned that you can use Docker Compose files version 3 and above, as far as I remember, if you are using Docker Swarm. So in that scenario, I can change this one to the version 2. I just have to remember that this section, networks with the DShop name, DShop network, will not work because it will not work with the version 2, okay? But the rest of it will work. And one more thing, for example, here I'm setting the volume for my Prometheus. So here's the mount volume, the named volume, which can be found here, which is fine. But here I'm trying to, mount the file, the Prometheus configuration file from my disk. So what I need to do, in that case, if right now I'm on my virtual machine, so I can go to the root directory, and whether I'm using the root directory or whether I'm using some subdirectory, well, I can simply provide the configuration file from my Prometheus, because I said I want to bind this file from my local drive, so it has to be available here. So let me copy the Prometheus YAML, and let's just put it here. I'll make the Prometheus YAML file, save it. Okay, and now it should be good to go. So version 2, I mounted the Prometheus file, and let's try to deploy this stack. It will take a while because at first you will have to grab all of the images from the Docker Hub or from the other registries, but
yeah. But I must say that this is pretty impressive because this is I know a lot of people that actually struggle a lot with the Docker, and not everyone is very I would say the enthusiastic and optimistic about the whole console stuff, and for at some point, of course, you have more options and control. Like I can imagine, using the Git rather than just plain console. But this looks pretty cool, especially when you have a lot of containers and networks that you need to manage. I think that for some administrators or DevOps, this could be pretty handy tool.
Yeah, this is really nice tool, and especially, since you can plug here many more Portainer agents, you can, run your production infrastructure and services using Portainer, which is a free tool, and sometimes it might be really enough for you. You might not even need Kubernetes or other orchestration systems. It will be just fine for you, or for some smaller deployments for testing, staging scenarios, and so on.
Yeah.
So as you can see here, we have our stack deployed. It says that control is limited because some of the parts were created outside. I think it's most related to the part that I had to, mount the Prometheus file, and it seems that our services are up and running already, just except the Fabio.
Fabio is down.
Yeah, but I think the Fabio is down because probably it started before the console, and it couldn't reach the console, so it failed. So.
Yeah, and it's based on the health check.
Yeah. So if I restart it, it should be up and running, and well, that's cool. So I can simply access all of the services. Let's say I want to access the RabbitMQ, and as you can see here, the RabbitMQ is there, right? So guest, and cool. Here's the RabbitMQ. Yep. Here is my, let's say, console, and I would like to somehow disable it, but okay, whatever. And all the services are up and running. And now I can get into the details of this container. I can do a few things. I can click recreate, and if there is a newer version, I can just check this pull latest image option. I can browse through the logs. So this is the std out. I can look into the stats. So basic stats, memory, RAM, the memory, CPU, network usage. I can go into this duplicate edit option, and here I can change the volumes, networks, and other options here. And I just click deploy container, and it will create a new container with this updated configuration. I can also click on console, and yeah, right now I'm inside my container. So this is the docker exec command. So I can do a lot of cool stuff. I can really manage my containers here. I can also go to the stacks. Okay, I have the total control now. Cool. So everything is up and running. I can simply, remove the stack or edit it and redeploy. All right. So let's try to create another one for the services. So I will create a new stack and I'll just call it services like this. And we'll probably get an error here. Yeah, and the error states, there is some issue. And the issue is with this one, because as I said, we have to use version 2 unless you use Docker Swarm, which can handle version 3, I think. So this network stop will not really work as you expect. But right now I'll be able to deploy the stack. And because we've made this deployment as a 2 separate stacks instead of 1, so there will be the infrastructure and the services stack. As you can see, more containers should be visible here.
So which part is not supported in version 2? The network part?
Yeah, I mean, except the other parts of the version 3. I think mostly, like for us, mostly this network tab, because here I wanted to create the network named DShop network, and in the services I wanted to join to the already existing network.
Yeah.
So as you can see, right now it's creating the services, the containers. As you can see in my, for example, Mongo tab, Mongo container, I can find that it's using there's the network. Okay. It's using the infrastructure DShop network. So it uses the stack name underscore and the network name like this. So it'll be infrastructure.dshop, right? So right now, once we deploy the new stack with our services, as you can see, they are not working simply because if I go, for example, to the API, I will have to change the network from, again, the services DShop into infrastructure DShop, right? But if I change this network and I redeploy the container, it will work just fine. So what you can do, well, you can either deploy everything as a single stack, but then here you would say something like restart always, because as you might remember, we had this issue where the service, whether it's API or some other microservice, it would start, but the RabbitMQ wouldn't be available, so it would crash, right? And if you don't have some internal retries for your applications, you need to restart it, for example, using the Docker CLI. So it's really up to you. But as you can see right now, the API is up and running. And again, since I exposed all of these ports to the outside world, I can go into my API and it's working. Yeah, that's cool.
So you need to apply change the network for each of the container inside the stack, right? So you cannot change this globally for the whole stack.
No, you can, as far as I'm aware. So you would have to fix your containers, simply the network, or deploy all of them as a single stack. And this is just a one-time job, really, so it's not that painful. Yeah, and this is how we can deal with the Portainer, right? So pretty cool stuff, free to use, and as you can see, quite powerful. So you can stick to Portainer, and you should be just fine. All right.
But, the only issue I see with the Portainer is that we actually, what you've done was like you took the Docker Compose file and you put this on the DigitalOcean virtual machine, but when we have the microservices, we would be more like scalable, right? So we would like to have some options for independent scale, to scale independently each microservice and orchestrate this one way or another.
I mean,
so I believe that this is more for like small solutions or for developer purposes, right? It's not like
you can do some real scale with Portainer, because as you can see here, you can use the swarm deployment mode, and the swarm will take care of horizontal scaling of your services and all this stuff. But we'll not be using Docker Swarm. And we'll actually get into the Kubernetes topic in a moment. But before we do, let me remove all of this stuff. So I will just simply destroy the stack, and I will also destroy the services, and let me do one thing, because I'm not sure why it gives me this warning all the time, so I'll just create a new droplet. I don't want to see this dangerous information all the time. And I'll make the same droplet. It doesn't have to be that powerful. And let's make it like this. And I'll just call it DShop rancher. I'll tell you why I call this rancher later on. And let me start this one. It's
Spoiler alert.
Yeah, spoiler alert. Okay, Frankfurt. Yeah, seems fine. So, well, basically, I will remove this container, this one. Let me destroy this. Destroy. Okay, and now we'll have the brand new container, and we'll use this one for the other type of deployment. But before we do, we'll have to go through the very yeah, it's a very quick deep dive into the Kubernetes itself. Just let me install the Docker first. So I will also show you how we can install the Docker using this longer tutorial maybe. So let's try to do it this way. I'll just say Docker install Ubuntu one more time. And let me split the screen. So this one is gone. And it's gone. Okay. Here is my new IP, and I should be able to connect to this one. Yes. Okay. So I'm on my new virtual machine using Rancher, and here is the installation of the Docker. And yeah, let's do it this way this time. Update. Then I need to grab this one. This one. So as you can see, even if you've never used Linux before, with most of the stuff, you have this these nice tutorials, and you basically just copy the commands to your terminal, and this will install all this stuff for you. So it's really simple stuff. Okay.
Yeah, you don't even have to read the description. It makes no sense to bother you. Yeah.
And the final one.
we have no clue what we're doing.
Okay.
Yeah.
And we should be good to go.
So this installation includes also the compose?
Yeah, let me check. So with this one, we have the Docker. Yeah, as you can see, it's newer version, so it's 1809, not 1806. Oh, yeah. And I think we also have the Docker Compose, but probably in the old version. All right, we don't have Docker Compose. That's weird. Sometimes it will install Docker Compose, but actually we don't need Docker Compose for this virtual machine.
Yeah,
we only need the Docker, so we are fine. Okay, so now let's get into the this very quick deep dive into the Kubernetes. Because before it's just like it was with the Portainer. I mean, before you start using Portainer, it's really good for you to know how the Docker works under the hood. What's the container image and what all of these tabs like volumes and what do they mean? So meaning that you should probably spend a few hours at least and play with the Docker CLI to really understand how the Docker behaves, right? All right, so we'll do the same now before we get into the nice dashboard, which allows us, to like click and click all the stuff and deploy all the stuff with clicking on the dashboard. Let's find out what's really the Kubernetes about. I mean, this is a topic for very long hours.
for another video series. I would
Yeah,
say.
I guess so. But we'll make it very short so that you really feel the very basic concepts of the Kubernetes. One thing about installing Kubernetes is if you're running Windows or Mac and you have installed Docker, you can simply go into the options or preferences depending on your system, and here you can basically enable Kubernetes, and you are good to go. It'll take maybe a few minutes, and that's it.
Yeah, the only thing it does is actually it installs the local cluster for you.
Yeah.
So yeah, it takes a few minutes and.
Yeah, you can also
or you can do this manually. I think that if you'll go for install Minikube for Windows, I think that works for both for Windows and but the most popular I would say that was the Minikube that as a standalone cluster.
Or for example, if you're using Linux for your development environment like I do, then you have to go for this installation just like we did with Docker. You just need to copy and paste a few commands and it will install the Kubernetes for you. All right. So what are we going to do? And before we jump into our DShop project, because as you can see, there's a lot of stuff that should be somehow set up and configured. And as you can imagine, we'll have to configure RabbitMQ, Mongo, Redis, and a few other infrastructural parts to make it up and running. Instead, I will use a very, very small app that I have prepared for the workshops, and you can find it on my private GitHub. And I just named it Nano Service. It's another, yeah. It's a very simple app. It's called Nano Service, and you can simply clone the app. And once you clone this, which I have done here, just check out to the workshops branch, like I did. And within the workshops branch, you will find a few additional files designed for the Kubernetes. And before we start using the Kubernetes and telling what this is about, let me show you what this app does. So I can open this up. Okay, I have it open here, and this is just a single file. Sorry, the single file application. Everything is in a program CS. There is no MVC. This is just routing, router, and a few paths. So we have path for errors, we have path for health, and we have path for generic path returning the name, the ID, which is the GUID, the file. It basically loads the file from this. This loads the content of this file, returns the content, and it also has this additional endpoint called next. So what it does, it asks the next instance of the service using HTTP client, grabs this message and returns this message and prints it on the screen. So with this simple app, you can test a few things like starting your application maybe through Docker, maybe through Kubernetes. This is just a sort of sandbox, loading files and the service discovery, actually connecting the files, connecting the services within your Docker network. So
that's cool.
This is a very simple app that you can play with. So let me open this the app.
Yeah, and actually worth to mention that a very little number of people actually know that you can completely get rid of MVC inside
you can.
ASP.NET Core and use the routing instead.
This is really cool.
So,
you just add the routing here, and here within the app you can just use router, map, get, post, and a few other verbs of HTTP protocol, and have your microservice even in a single file if you want. So this is really cool.
Yeah, this is a really lightweight solution. Actually, we could get ASP.NET Core in our
I think we'll at some point in the future maybe we'll prepare some another example using this approach. Okay.
Worth mention.
This is really cool. It reminds me sort of Node.js or Nancy. This sort of writing Nancy. The APIs. All right. So we have our app at localhost 5000. And this app, as you can see, there is my hello from our service. I can type /ID. It returns the GUID. This is the static ID. And I can also type file. It will return the file contents. And I can also type next. And it'll try to ask the next service for the data, but there is no next service up and running. So let me start it like this. I will call .NET Run with URLs, and I will point this one to 5,000. And I will start a separate instance of this app. So let me open new tab. And I will get, okay, and one more time, .NET Run, but this time with 5001. Meaning that I will have 2 instances up and running. And this one should work now. Okay, it works. So you can see the 5000 message, and then it asks the service on 5001 to grab this message through HTTP call. Yeah, I don't want this. And return it here. And you can find in the app settings JSON that you can override the settings here. And you can also override the settings through the environment variables, like here.
I really, it's really good that you showed that you had this put into the app JSON, because I was like, Jesus Christ, how did he manage to guess the address of the next application? I was like, what? that was cool.
Yeah. All right. So that's the basic idea behind the app, and later on we'll get back into our DShop solution, which is a little bit more sophisticated. So what do we do about Kubernetes, and what's the starting point of the Kubernetes? Like, besides that, it's really a container orchestration platform, but it's not the only one. You can use different tools. Sometimes these tools will use Kubernetes as its orchestration engine. Sometimes they will use something else. But you don't have to use the plain Kubernetes. You can use some pretty nice web interfaces to manage your clusters, and you can stick to Kubernetes or not. But the truth is that, at least for now, the Kubernetes seems to overtake the bigger part of the market, and it's probably the most. I think it's already by now the most commonly used tool for orchestrating your services. So
yeah, I would say so. That 2 years ago that was not so obvious, but if you put this, confront the Docker Swarm with the Kubernetes, let's say on the Google Trends, you'll definitely see that the Swarm is pretty much dead.
Yeah, so I mean, it's still
I
think it's still being not only supported, but also they still work on it, but I think it's more of an issue.
I think that there's a if you like, we have the Docker Hub, and they also had something like Docker Cloud, and that was for the Docker orchestration.
Yeah, for Docker Swarm. I used Docker Cloud in the past before there was Kubernetes, like 2 or 3 years ago. I remember these times. The early days of .NET Core. It was something.
Yeah.
All right. So what's the starting point? The starting point is the pod, right, of the Kubernetes.
Yeah.
So
basically.
Yeah.
Yeah. I wouldn't say. Yeah, maybe this is the starting point, but basically, I don't know how we can treat the pod in this case. I think that we can treat this as some sort of application that is put inside the Kubernetes cluster, and this pretty much may die, maybe up and down. So this is not something that is that's persisted for. We cannot guarantee that this will be actually available always.
Yeah, it's ephemeral, just like containers.
Yeah.
So yeah, if you think about Docker, and in Docker you have containers, which are your sort of unit of work, something that you deploy, something that runs.
Yeah.
In Kubernetes you have pods, and like the core difference between the pods and containers is that pod is an abstraction on top of the containers, meaning that in pod you can run Docker containers, but you can also run different applications. For example, you can use RKT containers. It doesn't have to be Docker. It can be also different technology. And by doing so, at first, when you use Kubernetes, you are not tied to the Docker. I mean, most of the people will probably use Docker, but they don't have to. So that's That's one pretty nice thing. And the other thing, which is also quite nice, is that within a pod, you can have more than a single container. So usually it will be just a single container. Let's say you have the RabbitMQ, or you have the API, or you have the user's microservice, and usually this Docker container, you put it into the pod. But if you want, you can add additional containers into your pod. And for example, you could say you could have something like API, and then next to the API you could have a Redis, and this could be, this could be available in a single pod. And so meaning that everything that's in a pod, all of these containers are reachable through the local host, so they know what the local host is. So you can, for example, say my API talks on the local host 6379, I think was the port to the Redis. You don't have to do any DNS resolving. They will also share the file volume and a few other things. So that's the idea behind the pod in general.
Yep.
Okay, so what do we do? I mean, how do we define the pod, and how do we work with Kubernetes? So we can work with Kubernetes using the command line, and we have this kubectl. Yeah, we have this kubectl command. And
do you have the cluster running?
Sorry?
Right now? Do you have the cluster running of the Kubernetes?
And one more thing about playing with Kubernetes is that, for example, here on Windows, on Mac, you have this option to change your cluster. So right now I'm using this Docker for desktop. So this will be my cluster for the Kubernetes. But I can also install this tool called Minikube.
Yeah.
And the Minikube is like another type of cluster for your local deployments using Kubernetes. And the good thing about Minikube is that it makes some things much easier, like getting the services, information, exposing dashboards, and a few other things. So if you want, you can also switch to Minikube. You can just install it through a CLI, and then you can access all of this, all of the Minikube tool simply by typing the Minikube command, and you can, expose dashboard services and do a few other things using Minikube. But I think we can just stick to the plain kubectl.
Yeah.
So with this one, we can do pretty much anything with Kubernetes. So let me type the first command, and I'll just type kubectl get pod. And I can also type get pods, so you can use both. And I'm asking the Kubernetes if there are any pods on my local host. There are no pods. So how can I run the pod? Well, on this workshop branch that I mentioned, we have these few files, and these are again YAML files, because with Kubernetes you use YAML to define your resources. And here's the definition of my pod. So what it does? Can you use Kubernetes, right? Not sure, do you use it for the production deployments or more for sandbox purposes?
More like the development purposes, and not that into the Kubernetes. But this is, I should be able to do this. I think so. So basically, we have the definition starts with so we have the kind, it's pod, it's obvious. Then we have the name and the labels. I'm not quite sure what the labels was for. I think that was just strictly for the deployment part and the services, right? So we add the deployment and the services to the pods that have the particular labels, right?
That's correct. That's correct. And one important thing, what also makes Kubernetes that cool is that you start with the API's version. And here I'm saying, let's say it's V1, right? So I'm using some stable, maybe production ready version of the Kubernetes definition. And within this V1, and if I type kind, I can see that here are a few different kinds, like pod, service, and a few others. But there are also different API versions. And as you will see, you can use different API versions. For example, some beta or alpha or whatever it is, like different types of namespaces in which lives different kinds of resources doing different things. So there are like stable, production-ready API versions, which are part of the core Kubernetes, And there are also some extensions, and you simply just define different API version and different kind of resource. Because
That is cool.
in Kubernetes, similar as it is, for example, in the Docker, this what you define here is a resource. So in Kubernetes, you have the REST API as well, and basically you can send a request to this REST API. And here I'm saying I want to create this pod, and within the metadata, I have to define at least the name of the pod. So this will be the name of the resource visible within the REST API of the Kubernetes, meaning that it has to be unique. If I create a pod using this nano service, whatever it is, pod name, it will be like unique name for this resource from the REST API point of view. And the labels is also very useful, because later on with the labels, we'll be able to, for example, move the traffic or use DNS resolver between services. So I will be, for example, I can type different types of labels using even different selectors. And I would like to say, I want to move the traffic to all of the pods, meaning, for example, all of the containers running or living within this pod named like nano service. And here is the spec. Basically, the spec is the definition of our containers. So it's similar to Docker.
Yeah, can you explain the image pull policy never? Because I'm not quite sure.
Yeah. So with this one, for example, here you could say something like always, right? So it will always pull the image from, for example, Docker Hub or the other registry. But in that case, since I'm using it on the local host, I have to do this a little bit of a trick. Yeah. Because I don't want this, for example, let's say I will build this image locally, and I don't want the Kubernetes to ask Docker Hub for this image. I want it to use the local version. So I will just make it pull policy never. So this is some sort of the hack or trick for the local deployments. And again, the last thing, my container will expose the port 5000, and that's pretty much all I need. Name of the container, the image I will use. So this is basically the name of the image coming, for example, from Docker Hub, like DevMentors /API, DShop API, or so, and so on and so on. And it also gives me these errors because here within this definition, I can also define the limits of my resources, like the available CPU, RAM, and so on. So what can I do with this pod? At first, I have to build a Docker image for this one. So I can simply type docker build -t, and I'll just make it nano service. I'll quickly build the image. I think I have to do the local deployment at first. Let me check. Work there, build. Okay. Yeah, sorry. I have to go because I was under the SRC and I had this previous Docker file using the published file on my own. So I'll go here and I'll use Docker build here, which is the multi-stage file. And once it will complete building the image, I will be able to create the pod. So in a moment, once it's completed, okay, I should be able to now apply this pod. So here in this directory, where is my pod YAML file, I can type kubectl and apply -f and pod YAML. So I want to apply the changes from this YAML file. And as you can see, I have this auto message saying the pod was created. So I can type again, get pod or get pods. And here is my pod, meaning that within my Kubernetes, I have created a pod which is built, which contains this nano service container. So I have the application actually up and running here. What I can do if I like to see what's going on with this app, whether I can access it or not, I can do this port forward, name of the pod, and then public port and the port of my container to quickly expose it to the outside world. So let's see if it will work. It says it's forwarding this, so I should be able to access it. And cool, it works.
Yep.
Yeah. So I managed to create a pod on my Kubernetes cluster and expose it to the outside world. And as you can see, I have this Docker environment here, which was actually defined here. Okay, but this isn't something. This isn't the way to actually expose your apps. So this is how I can define pods. And if I make changes to my pod, I can again do kubectl apply. If I want to remove the pod, I can say kubectl delete pod nanoservice pod. And well, there is no pods anymore, right? As you can see, it's terminating. I have only one pod and it should be gone in a moment. But let's recreate this pod one more time. So I can just click, I can just type apply again. I can also type kubectl describe and then the resource type, which is pod, and the name of this pod, which is the name of the resource. And here I'm getting some description of this pod, what's going on, what's the node,
There were
annotations, and so on. Yes.
You have also the events, right, at the very bottom.
Yes,
So
this is actually interesting. The events, what's happening with your pod, like scheduling, pulling, creating, and so on. So there is a lot of things that you can check.
And you can also, I think, the log from the pods directly. So
yeah, I think you can do like kubectl logs, and then
or log. I don't know.
I think it was fine. It's just that
The pod.
not sure. Oh, sorry. I'm not sure if it's already up and running. Let me check. Yeah, I think it was terminated, and I have to apply it one more time. Yeah, it should work now. Logs, sorry, like this. Yeah, these are the logs from my pod, just like with the Docker logs. Yeah, so quite similar stuff. So if you know Docker, you should feel a little bit more comfortable with Kubernetes. Okay, so there's the pod, and with pod you define your applications, whether it's single container or more containers, and you just deploy the pods. Next thing is this thing called service. So what's the Kubernetes service? The Kubernetes service, as you can find here, is sort of abstraction on top of your pods. Because as you can see, once you start the pod, like this, you can really access your pod, right? Because, well, the question is, where does it live, right? I mean, it lives somewhere on the Kubernetes cluster, but again, you can't really access it because it's not exposed, and you don't really want to expose your pods like we did with this port forward. So we need a better way, okay?
Yeah, it's pretty much about the hiding all your the application, the infrastructure behind some facade that will be, or the gateway that will be only accessible and reachable for the outside of the Kubernetes.
Exactly, and also this is also the important part, right? Because the pods are mortal. The pods are ephemeral, meaning that when
they may die,
it's
like for the user, it's like should make no effect, and accessing them directly would be kind of weird.
Exactly.
Especially that, on the production. So.
Yeah, exactly. So since pods are ephemeral and they'll be deployed, redeployed, removed, restarted, and so on. You don't want the user to rely on a pod. You want some abstraction that will move the traffic into those pods. Okay, so there is this idea of defining services, and the services basically allows you to do this sort of DNS resolving and exposing your services, whether it's within the cluster or to the outside world, or whether you like to define the load balancer, and so on. Okay. So what we can do with this one? let me open the service YAML file, which is here. And as you can see, I have this kind service. And within the service, the same stuff. The name, which is the metadata name, which is just a unique name in terms of my REST API of the Kubernetes. So I'll just make it nanoservice.svc, whatever it is. It could be nanoservice and nanoservice here as well, because these are different types of resources, but I just want to be explicit, so I'll just name it nanoservice SVC. Again, labels, okay, whatever, labels, name nanoservice, it's not really needed here. The interesting part is here. So at first I'm saying, well, I want to use the type called node port. What does it mean? As you can see, we have actually 4 types of services here. The first type is the cluster IP, meaning that if I will use this type of service, my pods will be available or actually reachable only internally within the cluster. So if I want to expose maybe RabbitMQ or a database or whatever it is internally within my Kubernetes cluster, for the other pods to actually be able to reach this database, I can use cluster IP. So just like with Docker or Docker Compose, I will expose these ports internally, which is done by default by Docker, and I will not make them available to the outside world.
So this would be also a good solution for I would say that creating the services for our microservices, right?
Exactly.
Because we would like to hide them from the outside of the world. We would like to access them only through the API gateway.
Because you don't want this. Let's say pod A, pod B. You don't want this type of communication, right? What will happen and what you're going to do is the following. Instead of doing this, you're doing like this. Pod A, it talks to maybe service B, and then service B actually forwards this traffic to the pod B. So let's say this is the API, and it talks to the product service, and then internally this product service, it will, or maybe let's make it product service SVC, which is the Kubernetes service, and then it will talk to the product service, which is the pod. So the communication between your pods will be done through the services, because this pod might die, this particular pod might die, or you might have, which is usually what you want to have, tens or hundreds or thousands of product service pods. So you don't really need to care about to which pod you should talk to. You just talk to the service, and the service will do this service discovery. And what does it mean? Well, it means that you can basically get rid of Consul or Fabio only if you are fine with the simple round-robin approach. If you're not, then you need to install some additional service discovery and load balancing tools. But if you're fine, you can get rid of the service discovery tools and just rely on the Kubernetes services. And that's fine. There will be a round-robin approach. Okay. Yeah. So we have this pod definition. If you want to expose your pod to the outside world, you can use this node port, which will make it reachable from outside of your cluster. And you can also use the load balancer. But if you want to use this one, then it's really you need your cloud provider to have it configured. Because, for example, you can use it with Google, Amazon, Azure, and it will expose your pods using load balancers that have to be available as a part of your cloud infrastructure. So it's really not for bare metal deployments. It's really for some subset of cloud providers. So basically, you will stick with cluster IPs and the load balancers. Here. And
the node ports.
Yeah, node ports. So here I said I want to use TCP. And the target port is the container port. So it will redirect the traffic from port 80 to the port 5000, right? Which is the container port in that case. So for example, if you would like to talk between service A and B, or between pod A and B, and the pod B has the 5000 port for its container, you will not ask unless you specify the port here to 5000. So you will send the request pod A, then service A on port 80, and it will move the traffic to pod B on port 5000, right? So this is the port, and this is the target port of the container. And the interesting part, the most important part, is the selector. So this is why we define here these labels. Because when I define here the labels, name is nanoservice, right now, whenever I will ask this service, or I will send a request to the service using this its name, it will just move the traffic to the pod, leaving, or the pod selected using this selector name nanoservice, which is this one, right? So this is the the magic. How the service is aware of the pods.
Yeah, this is really cool feature.
It's really cool.
Of the Kubernetes,
and it doesn't care how many pods are there.
Bind them.
Yeah.
Yeah.
So no more talking. Kube apply and service. Okay. We have the nano service available, so you can type kubectl get service. And as you can see here, there is my nano service SVC. And let me also type kubectl cluster info. Okay, so this is where my Kubernetes is up and running. And let me check the kubectl get service, and it's nanoservice dash svc. So I should be able to reach this one at this port. So let me try. Cool, and it works. So as you can see, the Kubernetes, since I made this service to be of type node port, it exposed it globally, meaning that it's reachable from the outside world using some random port starting from 30,000 plus. It has range below 4,000 ports, right? So it was something random starting from 30,000. You can change it. If you like to have here maybe 80, you can change it by running some Kubernetes option, but by default it'll be 30,000 plus, like this. Okay, so right now, even if I will add more pods, it will use the round robin, and I will access this one, which is the service, which is not really mortal unless I explicitly remove it from this Kubernetes, and it will move the traffic to the pods. And the last thing, the deployment. So where is really the power of the Kubernetes? Yeah. So yeah, here you can see we're using different API version, extensions beta 1. We have this deployment deployment type, and we have the again the unique name. And here is the deployment definition. So I said I want to have 3 pods, 3 replicas. So let me just remove the current pod. Delete this one.
Yeah, I think that's worth mentioning that the deployment itself underneath uses the replica set, and this is the separate component that is available in a Kubernetes. So basically, the replica set takes care that it makes it's best to make sure that you will have the number of replicas for the specific pod as you want it, right?
Mm-hmm.
So if you will kill one of the pod that are running, the replica set will take care to recreate the one and to make sure that the number you defined is reachable.
Exactly.
Of course, through the services. So that's why we reach them through the services.
Exactly.
So this is
So this is really cool. This is really cool. This is where the horizontal deployment, doing zero downtime deployments, automated scalability, and so on comes into play. So we want to have 3 replicas, meaning that we always want to have 3 pods. The metadata, so the label nanoservice, and the container, basically the spec of my container, which is the same. So this part is the same as this part. So what I can do with this deployment right now, saying that I have these 3 pods, and I want them to run the nano service again. So one more time, kubectl apply.
Yep.
And let's see. I can now type get pod or get pods. As you can see, it created 3 pods. It's creating 3 pods. And I can also type kubectl get deployment, and here is my deployment, and I want to have 3 pods, currently 3 pods, 3 up to date, 3 available, meaning that
can you now kill one of the
yes,
services?
I can. Just one. Yeah, sure. Just one sec. Here are the pods.
Yeah, so running.
And let me see if it's actually up and running. And everything is up and running, and it's cool because, as you might remember, I made those pods, which is, so this is the template, which is this part. I made this deployment, use the name nanoservice, and since I didn't do anything with the service, and the service uses the selector name nanoservice, it will move the traffic into those pods, right? Because the deployment created the pods for me using the same key values, meaning name nanoservice, and the service will look for these pods and redirect the traffic here. So this is really cool. What I can do, like I said, I can remove the pod. So I can say delete pod, and maybe let's try to remove this one. And let me get the pod. And as you can see, it's terminating this one, but it's creating a new one because I said I want to have 3 pods. I want to have 3 replicas, right? So I'll always have at least these 3 replicas. There are also other cool things that I can do with deployment. I can do scaling. So I can type scale deployment, name of my deployment, and I can say I want to have 5 replicas now. So in a moment, I should be able to get pods, and as you can see, there will be 2 additional pods added to the pool, meaning that I have now 5 pods. And one last thing that you can do with deployments, which is really, really nice. Let's imagine that I will do the following. Within my nano service program, I will change it. I will change my nano application to render the message like this. So I will type v2 and the message. Meaning that, okay, I created the new version of my app and I want to deploy it. And I want to do it using Kubernetes and the deployments. So I will quickly rebuild the image. So let me build a new image. I will just tag it with the v2, nanoservice v2, tag, docker build. And let's see what we can achieve with the Kubernetes and the deployments. So,
actually, this is one of the best features I've
this
seen.
This is the killer. So
especially that you can switch to the older version. Really easy.
So look at this. Look at this magic now. I can type this quite log command, which is the following: kubectl and ctl.
You have the typo.
Set image. Sorry.
Finally, I could say that. You have the typo. That was not me.
So what I want to do, I would like to update the image. Here is the deployment part, and this is the name of my deployment. And I would like to update the nano service, which was my current image, to the nano service v2. Okay. So let me check kubectl get pod, and as you can see, it started removing some of the pods and creating the new ones. So right now we have a truly 0 downtime deployment, because by default, as far as I'm aware, the deployment will ensure that at least 25% of the pods of the previous versions are up and running. And for example, if you have 5 pods, it should keep at least 1 pod. Sorry, if you have 4 pods, it should keep at least 1 pod still available in the previous version. And then, terminate the 3 other ones and redeploy them using the newer version of the image. But you can, of course, configure it. So right now, we should have the new version of our app deployed. And it is, right? V2. And there was no downtime while deploying the newer version. And what you can do, let's say you made some terrible mistake and you want to quickly, revert to the previous version. So you can at first type kubectl rollout, and you can type history. I want to see the history of my deployments. And you can see I have revision 1 and revision 2. I could look into the revision details. I could add some comments to those revisions, but let me quickly type the following: rollout and undo. So I would like to undo this deployment for this one. And if I would like to switch to the particular revision, I can type to revision and the number, let's say 5, given that I have revision number 5 here, so I can jump between different revisions. But if I do it like this, I will just get back to the previous revision, and it will recreate the pods for me using the previous version, and I should see the previous version in a moment, actually.
It is the older.
Yeah, let me just ensure that it's also here. Let's say kubectl. It's loading. Okay, so I have the previous version of my deployment available. So very simple stuff. It's like git checkout and move to the previous commit or another branch. This is really cool.
And you can also attach some messages for the particular rollouts. So you'll see if you will update to your deployment to some newer version, you can actually add some comment. It will be much easier when you're seeing the revision history, the rollout history. You will have some, as you see now we have the change cost none, but you can actually put something there, something meaningful, which will help you to, in case of rolling out, to actually know which version is fine for you.
Yeah, this is really like very, very few concepts. But I think that by now you should see how powerful the Kubernetes can be. Another thing that we don't want to talk about in this episode is that if you want to do the load balancing and you want to expose your services to the outside world, you shouldn't really do it using node ports. Here is where this thing called ingress comes into play, and how you can define your load balancing or the rules for your reverse proxies and so on. So you could look for the ingress, Kubernetes ingress, and maybe the Kubernetes Nginx ingress controller if you are interested in that part. As you can see, what I did here, I just typed I want to start the Minikube because I just wanted to quickly show you the Kubernetes dashboard. Hopefully it will start quite fast. But well, it turns out that even though there is a dashboard for Kubernetes, dashboard, which you can find, for example, here or here. For the plain Kubernetes installation, you have to install it manually. As far as I'm aware, there is no like single command that will start the dashboard for you. So you have to install it as a sort of extension, I think. Yeah, okay, you have to do the deploy it using kubectl apply. So this is quite simple, and you can browse the dashboard. But if you are using Minikube, not sure what it's
Minikube UI or something.
Yeah, you can just type Minikube dashboard like this, and it will open the dashboard. It will open the dashboard for you. Oh, okay, it's almost there.
So it's the dashboard. It's sort of the equivalent of the Portainer for the Kubernetes.
I mean, not.
So you can actually.
It sort of is, but it's not that useful as the Portainer.
No, what I mean is more like you can actually browse your pod services.
That's correct.
Your, like replica sets, So
you can,
if you want to get rid of the console, it's probably a good way of,
Yeah, but there isn't much you can do with the dashboard. I mean, you can paste here the definition of your resources from the YAML files and deploy them, but it's not that useful. It's more like for informational purposes. So
more like read purpose.
Exactly. Yeah. So it's still deploying, mostly because I had some components up and running already. Okay, but it should be there. No, okay, so Minikube dashboard, and it should open a dashboard for me in a browser.
I think that you need to put additional parameter like -o for this. Maybe.
Oh no, I think it's loading. I think it should open the dashboard in a moment. I think there was no additional parameter for this one. Let's see. Let me just browse through the history, but I'm pretty sure there was just dashboard. Yeah, so it should open. It probably tries to do the kubectl apply under the hood, and configure it. So it might take a little while, but it should start soon. Okay, so let me close the tabs to the right for now. It will open soon, I hope. Yeah, and well,
Great.
So yeah, again, you can do everything for the CLI, but sometimes you may not want to do it. So what you can use, there is quite a lot of tools that you can use for orchestration using Kubernetes under the hood. One of these tools is Rancher, they really like, but there are others, like there's OpenShift. There's the PKS, whatever it is, by Pivotal. There is the Mesos by Apache, which is quite different, but it's also another type of tool for orchestrating your services. So you can look for the Apache Mesos, the OpenShift, the Pivotal stuff. So you can use these different type of tools for managing your services. Some of them will work on top of Kubernetes or integrate with Kubernetes in some way. So I will show you one of these tools, which is the Rancher. And Rancher is pretty cool. It's very powerful. It's free to use. If you want to pay for it, if you want to have enterprise support, then you need to pay for it. But besides, it's free to use. I think it's free to use. I'm pretty sure, and it's also open source. So how can you start with Rancher? Well, I'll just type Rancher install, and
it's another Docker installation.
Yeah, that's true. So I'm on my new virtual machine here, which is this one. Okay, let me see here.
Minikube dead or something?
I'm not sure why it's hanging.
Can you type kubectl get nodes?
Oh yeah, as you can see, there was some error. Yeah, maybe because I started employing some stuff into my Docker for desktop, so maybe there was some. Not sure. There was some conflict, but it used to work. So okay, so here we have the Rancher. We have the single node installation and a AJ installation. So we'll go with the single node, but for production, you'll probably go with this one. And well, provisioning a Linux host. We already have the Linux host. We have the basic requirements met, and we want to run it. So if I want to run it, for example, using default self-signed certificate, I can just copy this command and put it here. Yeah, okay, let's keep the Minikube for now. All right.
So now we're back on the DigitalOcean, right?
Yeah. Now that we are the Kubernetes ninjas, we can use some serious tool to manage it. So we don't have to stick to the terminal for our whole life.
Okay. Okay. You have the new droplet.
Yeah, I created a new droplet. So we should be able to access our Rancher UI. Just let me copy the IP address, and the default port is 80. Again, privacy error because it tries to redirect to the 443 port. I'll just proceed to the unsafe. And here is my Rancher dashboard. So at first I have to set up some password. Okay, continue. And I want to use this URL as my server because I created this virtual machine. I want this virtual machine to be the server for my rancher, which is the rancher is the orchestration system. In the previous version, it used to work with different orchestration mechanisms, also including Docker or their own cattle and Kubernetes. But since version 2.0, there was a recent release, version 2.2. It works with on top of Kubernetes. It gives some additional features, makes life even easier. So let's create a cluster, right? So just like in Kubernetes, we have cluster. We'll create a cluster here, and we have different integrations with different providers. For example, here I could do the custom, and given that I want to run everything on premise or in some private infrastructure, I can just do the custom. Deployment. I want to have a cluster name called DShop or DShop Prod or whatever it is, and here I would click next, and it would show me this. It will show me this command that I have to run on my agent. It can be the same virtual machine, or probably better a separate virtual machine, and it will just start this cluster by connecting these agents, right? And one more thing about agents, and in Kubernetes we have this three parts. So etcd, the name comes from the Unix etc. This is where the Kubernetes keeps this configuration. This is sort of key value storage, so it keeps the configuration. Everything is distributed. Control plane is basically a scheduler for the Kubernetes engine, and the worker is where we deploy our apps. So pretty simple separation. Okay, but I don't want to use this one. I'll just create a new one. So let me delete it, and let's create a new cluster. And I will create a new cluster, and let's say I want to have integration with DigitalOcean. So what I can do here, at first I need to create a template. I mean, I could run everything on my single virtual machine, but let's say I want to plug in a few additional virtual machines. So here I will say the following. I want to add a new template, and I will call this DO because this will be the credential for my DigitalOcean, and here I need to pass the access token. And you can find these access tokens pretty much for all the cloud providers. Like you have access token for Azure, AWS, Google Cloud, and a few others, meaning that you can work with their APIs for the CLI. And here it was somewhere.
Wasn't that under the access?
Yeah, it was.
When you get back to droplets?
No, I think it was in the security tab. So let's see, certificates. Let me check. I always get lost with this. Okay, there is a link. So cool. Okay. So here I can create a new token. As you can see, I have some old token here. So let's make it DShop Rancher, whatever the name. Here is my unique token. I will paste it here. Okay, it will connect. And now I can choose a droplet. I want to use the Frankfurt location, Ubuntu. Okay, that is fine, 2 gigs. And the name. So let's say this will be my DShop etcd template. Create. And that's the first one. Another one, I'll create a new template. So again, using DO already saved credentials. Again, Frankfurt, Ubuntu, and I'll make it the control plane. Like this. Okay, create. And I'll make it the template for the control plane. And the last one, the pool for my worker nodes, so DigitalOcean credentials. Waiting.
Yes, kind of. Takes a while.
Yeah. Not sure why. Okay. And the last one, the, let's say, worker template. Okay. The cluster name, I'll just call DShop. I'll stick to the default options here, and let's create it. Oh, sorry, the prefix is required, and the prefix, where was the prefix? Oh, there's the prefix. So let's make a prefix like this. Control plane and the worker, whatever. Create. And setting up the cluster for the first time, it might take a few minutes, but it will get the job done. So what we can do with Rancher, so just a quick view. Here we have the API key section. So if you like to integrate with Rancher from your apps, you can do it like this. The credentials. So here is where I make credentials for DigitalOcean for the integration with the particular cloud or some virtual machines. There are my node templates that I just created. Here are the preferences, so I can switch to the dark mode. I think I like the light mode more. It looks nicer.
Yeah,
I think.
in this case, yeah.
What else? We have some tools. For example, I can enable whether I want to use this Helm. I mean, we didn't talk about Helm, but basically Helm is some sort of package manager for Kubernetes. So if I like to access the Helm, the packages created for Kubernetes that I can install, I can enable it. Here are the drivers. You can see I can enable some extensions for different clouds. Some of them are enabled by default. The security. The security is quite nice. This is quite. We can define quite grained security here. Different access policies, different roles, different types of users, and this is nice. Different types of authentication like Active Directory and GitHub and a few others. The settings of my Rancher server users, and here the apps. So if I would like to start the app just like that, I can just click the launch here and browse this catalog for the different apps. Let's say I was looking for some databases, and okay, I want to start Redis, view details. I can set some configuration here, and basically I can quickly deploy and launch the app coming from this catalog. So this is quite nice. Cool. Yeah, that's quite cool. And here is our cluster section. So right now it's deploying, it's configuring all of these virtual machines within our cluster. It will be available soon. And if I refresh my DigitalOcean's page, my droplets, you can see that because we added the access token to the Rancher, we should see here quite soon additional droplets. Yeah, but I think the droplets, I think there will be not in this section, because in DigitalOcean you have this project section. There will be visible under the general section. So here's the droplet for my workers. As you can see, worker 1, control plane 1, etcd1. Here are my droplets, just different virtual machines, and Rancher deployed them for me. Yeah, as you can see, even some other cool things, like you can provide some certificates and rotate the certificates. You can create a snapshots. So basically you can create a snapshots and then back up them somewhere, restore your snapshots. So a lot of stuff you can do with this tool. Everything is open source, everything is for free, and this is really powerful and really nice. Still provisioning, but here we can see the details, what it does. Should be available soon.
Yeah, maybe in the meantime you could try this Minikube dashboard once again.
Okay, let's see. Maybe. I'm pretty sure if really I restarted the the Docker and the Kubernetes cluster, it will just work. Let me check one thing also as well. Get deployment. let me try to remove delete deployment. Maybe it has some conflicts when it tries to stop this cluster. I'm not sure. I can also try to switch to the switch to the minikube. So yeah, I mean, this is not the most powerful MacBook, so usually it would take much faster, but sometimes it happens. Okay. Oh, we almost have our cluster. It's not ready yet, but it's still trying to activate the worker. But as you can see, quite some nice dashboard here. CPU usage, memory usage, like usage of our pods, and some general information about the machine. What is also nice, we could launch the kubectl here. So if you want to do something with our kube Kubernetes for the CLI, we can do it here. This is why we said it's good idea to actually know what's going on using the terminal as well before you start using some web user interfaces to manage your services. And it seems that everything is available now. So let's see. Okay, here is my rancher. Cool. Before we begin, let me get into the cluster. So okay, I'm in a cluster, and within a cluster, I have like nodes. So these are my virtual machines, so I can see what's going on with them. And what is also great, let's say I want to have more workers. I can just click plus here, and it will create a new worker for me. So if I refresh my DigitalOcean's page, you can see we have new worker, which means scaling your workers is as simple as clicking the plus icon here, or even changing some rules on the Kubernetes or on the rancher level, saying that, hey, I want to automatically scale these virtual machines if there is CPU usage greater than maybe 50%, right? So this is really nice. And this is how you make your web applications always up and running. Like if you are the next Amazon and there is a Black Friday coming, this is how you scale your apps automatically. Okay, so here are nodes. Here is the storage. So if you want to define storage settings, like for volumes, you can do it here. And you can see a lot of integrations with not just local volumes, with, for example, Azure Disk, file systems, Google Disk, NFS, and so on. So this is some real, this is really how you want to use volumes, not just the local volume. You want to store your files somewhere in the cloud, which is, replicated and so on. But let's get into the project namespaces. So in the Kubernetes, you have this concept of namespace. And the namespace is just some sort of logical separation between your resources, just like in Visual Studio. It's not a physical separation like different files, just a logical separation. And Rancher also adds these projects. So project is just like a namespace, maybe one layer above. So let's say we want to have the project, and I'll just call it DShop. Okay, we can assign some different users with different access policies to this project. So here's my DShop project, and within the DShop, I can create a namespace. So let's just say I want to have the services namespace here. As you can see, I can define different usages, different quotas for the CPU usage, and so on here. So here is my project with the services namespace. So if I open my project now, and there's additional few tabs, but let's say I want to deploy the app. So not the best part is that, I said not a best part is that with the previous rancher, you could simply import your Docker compose. But since we are running with Kubernetes, you can't really import your Docker compose. What you can do, there is this tool, it's called Compose.io, I think. So if you have the Docker compose file, you can install this tool and use it to convert your Docker compose into the Kubernetes files, Kubernetes deployments files. But for example, for our infrastructure compose, it would create as many compose files or even more. I think 2 files per each service. So that's quite a lot. But you can do it like this. So you can really deploy your services through Docker Compose here. But once you do it, you can just export your YAML using the Kubernetes deployment and then redeploy it much easier. So let's say I want to deploy something here. And I want to deploy the RabbitMQ. So this is the name. And I will use the RabbitMQ free-management image. What's management? Like this. I can expose the port. So I would like to expose this one port from my RabbitMQ on the random port. I can set up some variables here, volumes, and so on. Let me just launch it. And it will grab the image from the Docker Hub and it will expose it. I can go into this into the details and I can see the logs, but it's not available yet because I think it's still downloading the image, and this is the first deployment. So it's pulling the image, yeah.
Yeah, so this part itself does not require any.
Yeah. Oh, I made a typo here.
You could see. Yeah.
Yeah. Sorry.
Where do you have to?
Yeah, I made a typo in the image name. Sorry.
Management.
Management. Yeah. Like this. Correct. Upgrade. Okay, so it's already creating the container.
So underneath you'll have the pod running or pod with additional service on top of it.
This is the pod with this worker container.
Okay.
But it's not just the pod actually. As you can see, I'll be able to access my my RabbitMQ because they have this concept of workload. So they make it a little easier for you. You don't have to care about services if you don't want to. They have this concept of workload. So here, as you can see, I can access it from the outside world because I made this deployment using I exposed the port, sorry for this one, using the node port. So I can choose like cluster IP or node port, type here, and I wanted it to expose the random port. I can do load balancing. So here's where I can set up the ingress. So if I would like to expose my application to the outside world using this ingress and load balancing capabilities, I can do it here. I can go to service discovery. So this is where are my rules for service discovery. So as you can see, once you create this workload, which is the pod, it will also create these services for you automatically. So you don't have to really care about it. You can remove them, you can change them. You can add the record. So I can say, I want to add a new service using this namespace that maybe points to this workload. So let's say I would like to have the DNS for RBQ to point to the RabbitMQ workload, and I can just create it like this. So let's go back to the workloads. Let's add another one. So I will deploy a new workload, and I will just call it Jagger. And let me just, we had this Jagger image. It was a long name and I can't remember. It was something like Jagger all in one.
It's like all in one, yeah.
So yeah, here is my Jagger. So Jagger, I know. This one. And
Jaeger actually, I think.
Jagger?
Jaeger?
Okay.
I'm not quite sure, yeah.
Yeah. All right. So let's launch this one as well. And we can add more and more services here. But let's also DShop service. So I want to deploy the DShop-API. DShop API. And I want to use the DevMentors and DShop API. If you have your own registry, you can go to the resources and you can use the registries here and add your own private registry. So you don't have to rely on Docker Hub. You can also set up other things here. Like for example, in Kubernetes, you have this concept of config maps where you can store your environment variables. You have concept of secrets. So you can set all this stuff here in this resources tab, as well as certificates. So you can just add the SSL certificate to the Rancher server, set up the load balancing for ingress, and all of your traffic will be encrypted, right? So this is cool. Okay, I don't know what was this about. And let's expose the port 5000 node port launch. Here is the DShop API. Jagger is up and running, RabbitMQ is up and running, and the DShop API should be up and running soon. And in the meantime, let me show you something very cool. It was, I think it was a cluster level. And cluster or global, I have to check. Okay, cluster. Yeah, there's like so many options, sections, different views with different menus that sometimes you might get lost when you use it. Okay.
Yeah.
Oh, tools, monitoring. So I can do enable monitoring. I'll just use default options. And here are the nodes. Let's see. For everything, for all of the different parts of the cluster.
And that was the monitoring for what? For the whole cluster or for?
Is the IP up and running, or what's the issue there? Yeah, that's fine. It was just a name. We have the issue there.
Is this the dot or not
What's
the dash?
The issue? I think we can connect to RabbitMQ. All right. Okay, so let me check. This is fine. This is fine. I think I know what's the issue. It might be that we also have to expose the port, which is the cluster IP, where our actual RabbitMQ exposes the port to connect to it. So I think we have to expose this port, and I'll make it using cluster IP because I want this to be only internally available within the cluster. So, because if you don't expose ports using services, you will not talk between pod and a service and a pod. So we have to keep in mind. Okay, it should help, I guess. Could be. Yeah,
so I think it could be. For the
Jaeger? And for the Jaeger,
the reporter will not
there was a lot of ports. Yeah.
I have no clue what was the port. I need to check. Yeah, we need to check in the app settings because that was the.
So only in the UDP port?
But this is actually the UDP.
Only this one?
So.
Or other ones as well? Oh, let's see. So at first, let me expose two ports. So the one for the UDP,
I think so, yeah.
and the other one for the interface. So it will be. It was this 1600s something. This one.
I don't remember what was the.
Let's do it like this. Okay, let's see if it will help or not. RabbitMQ. Okay, we have two ports exposed here. This is fine. And let's see if it works now or not.
Yeah.
Wait a sec. It might still. There's still some failure going on.
Looks like.
Yeah, it's probably something with the service. One sec. Okay, edit. This is fine. Let me just check. This is the correct port for the Rabbit. Rabbit. Okay, that's the correct. Okay. Oh, just it. Yeah, it just. Yeah.
What
Exactly.
is the error message for the
Let's see.
API?
Let me
It's
just
like
try
it just
to.
cannot connect or something.
Okay, this one is fine. Edit. Okay. Yeah, it can connect. Oh, it worked. So probably need to redeploy itself. Okay, cool. So it's working. That was just the issue with this part. So let's see. We can open the app and we get the Redis unavailable exception, but it's fine. We'll have to deploy the Redis as well. So let me open the API, which I can access here. Okay. And this is fine. We can connect Redis. We'll deploy it in a sec. Let me see if the Jaeger works as well. Okay, it works. Cool. So we can find a tracer for our API. As you can see, we have some exceptions already, so we can trace it. This is cool. What else we can do about it? So here's our RabbitMQ. So we can log into it. As you can see, we have the connection from our API. So everything is fine. One thing I want to show before we do Redis deployment, which will be the last thing. Since I enabled this monitoring here, as you can see, I have this new tab called Grafana. So I can expand it. And here I see the Grafana metrics, like the base metrics for all of the pods, like CPU, network, disk, packets. So this is really cool. And I can actually click on this Grafana, and it will move me to the Grafana dashboard running from the cluster. And here I can browse through different namespaces. So I run down a services namespace, and here's my deployment. So I can look into the DShop API, and I can see its basic usage of memory, network, and replicas. And I can go to Jaeger, see the same. I can switch maybe to the Kube system and see what's going to Kubernetes. So this is done by the Rancher, and I think they added this in the latest release, which was 2.2. It was like 1 week ago or something. This Grafana integration out of the box. So this is really cool. I didn't have to set up anything.
So this is the metrics.
No, it's nothing common. I mean, we can extend it with our Prometheus stuff, but this is done by the Rancher out of the box, and it will be done for all of the pods if we decide to. Right. Just like we did by setting this monitoring to true. This is quite cool stuff. And so let's try to deploy our Redis. The last thing.
Yeah. Very cool.
And the workloads. Deploy Redis, but let's say that I want to move the Redis to a different namespace. I'll create a new namespace and I'll name it infrastructure, because we want to have this, logical separation. So I'll start the Redis, and I think it was 63979 for Redis. Let me just verify. No, different one. No, I think it was this one. Let me check. Okay, that's the correct one. So I'll make this the cluster IP. Okay, launch. So in a Kubernetes, since we have this concept of cluster IP, pod, services, and so on, I need to do the following. I want my API to connect to Redis, but this lives in a different namespace, in an infrastructure namespace, not the services. So since I'm not using Vault for my configuration, to keep my configuration in a Vault, I will simply override the variable. And the nice thing about .NET Core is that if you open your app settings, you can override all of the variables from here, all of the settings from here, the JSON file, simply by setting the environment variables. And how do you do it? Well, you do it like this. the section name, which is the Redis, and then double underscore, because you could use colon, but usually it will not work. So double underscore, and then here is my Redis, and then a connection string. So like this. And if you were to override the, for example, the array, which is here, I would say RabbitMQ, sorry, this one, RabbitMQ, and then double underscore host names, and then double underscore, and then it will be, I think, 0, which is the first argument in the array. So it was 0 or args 0? I think it was just 0. Yeah, it was just 0. Just 0, yeah. Okay.
Yeah.
So let's make it. So we would say Redis, 0. Right? But if we're in a Kubernetes, we have this concept where there is a pod, there's the service namespace, and so on and so on. So our service is called Redis, and the namespace is called infrastructure. Let's see if I didn't make a mistake. Okay, it was fine. And yeah, it should be it. Cool. So let's redeploy the app. As you can see, we have 2 pods. So one pod is being recreated. The other one is still up and running. So there is also this sort of zero downtime deployment. So a new pod seems to be already there. And let's see if our Redis will work. And it works. So we have this logical separation between different namespaces. This is where our infrastructure services might live. This is where our microservices might live. And we just connected them with each other using this concept of the Kubernetes namespace. And we could even create a new cluster and connect the services running different clusters just by extending our name for this the Redis connection string value using the cluster name at the end of this connection string. So that's pretty much it. You can do a lot of cool stuff with Rancher as well. But as you can see, this is really simple. You can very easily add new nodes. You can scale your apps just by getting to the app. And well, I can, what was this button? My container. Sorry, sometimes I get lost. There's so many sections here. Okay, so I can, redeploy. No, I think it can be done even here.
That's fine, that's fine.
Edit clone. Was it in edit mode? Yeah, I could make it like this. For example, I want to say, let's say I want to have 5 pods always, so I can scale it here when I deploy it. But I should, okay. I can expand this and I can just click plus. I want to have 4 instances, right? And if I open this, you can see that it starts adding these pods. And by default, it will add those pods randomly, actually these workloads randomly on a different nodes. But I can edit my deployments, and within this section, I can change the scaling upgrade policy, and I can, for example, say I want to schedule the nodes using this rule, which says I want to make it maybe worker equals services. So I want to scale the services only on the virtual machines where the label worker equals services or whatever I want. And I can do health checks here, pretty much everything that you need to run your services in the production enterprise ready environments. So I think that's it for now, and I think we just hit like 2 hours. So
that was quite a lot of stuff.
What's the time? It's 2 hours?
Yeah, that was the longest episode so
that's
far.
Awesome.
So,
but I think that's good ending. The longest episode ever.
Yeah,
so
2 hours, over 2 hours actually.
Yeah.
Yeah.
That was quite an ending, quite a final episode.
That was
just like with the final of Game of Thrones incoming. Yeah.
Yep. Yeah. Right. So we reached this point after
I
I don't know
think it
whether
was
when we actually recorded the first episode.
yeah,
That
like
was the December of the previous year.
yeah,
We recorded the
somewhere
teaser, then we
like
just
December or
you
November.
have to
I'm not
wait
sure,
for
but
another 2 months
somewhere
for
around it.
the first episode. Yeah, because yeah. So it took us actually
It's
like 15 episodes.
yeah.
That was
In total, it's
at least for me. I
it's
think for
almost
you
20
also
hours
that
in
was a
total.
real
Sorry,
pleasure
so
to
it's
show
almost 20
all this
hours.
stuff.
Almost. I
And
mean,
the
it's
good
about
thing,
19 hours of videos in total.
yeah,
It's almost 20 hours.
20 hours. Yeah, so it's
Yeah.
now you know the reason why we need to make this video a little bit more, little longer to reach the 20 hours. No, but during this actually I think that we showed you quite a lot of things, starting from this whole implementing and the idea behind the microservices and different approaches, and going through some different tools and the implementation of code
Yeah.
itself. Yeah, and the good thing is that we have 400 stars on the GitHub. So on the DShop project itself, because then we have
It's 400.
some different numbers on each repository.
Awesome.
But the DShop reached
1,000.
400 stars. Yeah, so we just need to make it
Yeah, we are.
make it grow, and
We are in the
and we've
awesome.NET
just been
core.
added to awesome.NET, right? As far as I know. Yeah. So if you don't know this is definitely
Nice.
the place that you should explore, because there is a repository called awesome.NET Core, and there's also the awesome.NET, and basically this aggregates great projects from all around the world. So we are higher than the eShop on containers, and the reason is just because we are.
And there are also some other cool projects about microservices, so make sure to check them out using different tools. Thank you for watching. I mean, we're not saying it's the last episode ever, as there are a lot of different hot topics. Like, I think the hottest topic now is the service mesh. So this is something that we need to dive into and start playing with it. So service mesh. Can browse to service mesh and projects like Istio or Console Connect or Linkerd. So if you want to learn something very hot, very new, look for the service mesh and see what it can do for you. Maybe it's something that you actually need, but you didn't know that you need it. So look for this stuff. What else? One of the next steps is that we want to split our common package. So we have this common package and we want to split it into smaller packages, just like we said in one of the previous episodes. And I think that we'll start a new organization with some cool name. So for example, something like Pivotal did with the Steel.io, where they created these projects using Netflix stack for microservices, and they added these small tools, small packages for different different types of services and different types of infrastructural concerns. I think we'll try to do something similar with splitting this common.
Yeah, and the reason for this is just because
exactly.
Not every microservice require everything that we put in there. So over the months this package grows a lot. So we think that this is a good thing to actually move this to the independent packages and simply let you choose what is fine for your project. So we'll let you know on the Twitter or Gitter forum, whatever, that we actually move to the new repository. Of course, we will still have this common package, but we'll simply archive this. So just to let you know that this is not developed anymore. Once we actually move to new repository,
we also have the sub page for our course. So if you want to browse for all the episodes, you can go to the courses, distributed.core, and see all of them here. This episode will be also added here. And maybe the very last thing, you can find this workshop section, and if you open this workshop section, you can find here for now this microservices.net or actually .NET Core workshops. So if you click on this, it will redirect you to this website. We made like one version in English, one in Polish. And if you were interested in some, workshops, maybe for your company or some consulting services, feel free to reach us, whether through one of the channels like GitHub or Twitter or forums or Gitter, or by sending us a message. Yeah, by sending us a message here for this email.
Just use the mail or something. Yeah. Yeah, but basically the idea behind these workshops is that it's divided on two modules. So we have the basic module for folks that actually have never worked with the microservices. So we'll start with the very beginning, like the theory behind it, and how we can actually split or divide our domain and try to create a separated bounded context. And we'll just go through the very basic stuff. And as the result, we should have some microservices up and running locally, and put into some
managing,
containers.
monitoring, tracing, orchestrating.
It's more about the topics that and the things that are not that obvious and may not be an issue for simpler apps. So we'll definitely focus on some more advanced stuff. So the idea behind this is that you can either choose the basic module, the advanced module, or just pick M2. If you want to get a complex understanding of the microservices.
Feel free to reach us,
from the very
and I think that's it for now.
Today.
Thank you one more time, and that was a pleasure.
Yeah, it was a real pleasure. And
we'll be thankful for spreading the word about DevMentors and this course, because we've done it for you guys to share the knowledge. So thank you. And goodbye.
Be very cool. See ya.